What is up, everybody? This is Max,
Matt.
and we're back with part 2 of the OpenRocket tutorials. In this, we will be dealing with the Motors and Configuration tab and the Flight Simulations tab of OpenRocket. So, you have our rocket that we designed last time. It's a good example rocket. Has a good amount of components that you will see in rocket design. And the first thing we're going to do is add a motor to this configuration.
Motors are important because it makes the rocket go.
If you notice in the bottom screen, it gives you some basic information, length, mass, stability, but we don't have a calculated apogee or velocity yet, and that's because we don't have a motor input.
Apogee is how high the rocket goes.
So the first thing you want to do is select a motor mount. The options that it's giving us are the payload, parachute, and booster tubes. Essentially, it's picked any cylindrical object that we have on our rocket. Generally, you would have some kind of motor mount tube that you've designed into your rocket. In this case, the booster tube is designed to fit perfectly with a 54mm motor. So we're going to go ahead and select that, hit New Configuration at the top, and since this cell is highlighted, we will hit Select Motor.
Look at all those motors.
The primary motor suppliers that we will be
Using.
are Aerotech and Cicerone Technology Incorporated, as well as our own motors that we produce.
Star.
These are basically thrust curves that we can input into OpenRocket and use in our own files. So the first thing you're gonna want to do is to limit the motor diameter to the motor mount diameter. Essentially what this means is you can move these sliders back and forth and it'll get rid of motors that aren't within this range. And since we have a 54mm booster tube, we will only want 54mm motors.
We want them to fit.
So this will basically narrow down our options to what is still a considerable amount of just 2 providers at 54mm. You can go as big or as small as you'd like, but for the purposes of this launch vehicle, we've decided to go with an Aerotech I-65 motor, which you can see loaded right here.
It's fat.
So the first thing I want to note is that the stability, which was so nicely at 1.3 before, is now negative again. Essentially what's happened is our center of mass has been dragged back behind the center of pressure because of all this weight we've put in the back.
Shocking.
The Flight Configuration tab allows us to remove and replace the motor, and we can see the affected stability. 1.35 from before, and a gross negative with the motor. So with the motor input, we need to go back to the Rocket Design tab and change our fin size to 1.5 inches in height, which gets us back to a more reasonable stability of a 1.09 cal.
Fins are basically how you just fix your stability.
Yep. It's the easiest part of the rocket to rapidly change stability. So
And it doesn't affect anything else.
now that we have a more reasonable stability, I think it's important to note that this is a low stability. Stabilities below 1 are generally considered understable, and stabilities above 2 are considered overstable. This is a rough generalization, but I think it gives you a good idea of a rocket with a decent stability. Now that we have a motor in our rocket, we'll go to the Flight Simulations tab. First thing we want to do is go to New Simulation. This will bring up a dialog box. You can rename your simulation, select the motors, in this case we only have one, and change your launch conditions, which deal with wind, your launch site altitude, and your launch rod length. You can also change simulation options like the time step and the mathematical approximations which are used. We will click Simulate and Plot. Here you can list the flight events which will be available in your simulations. You can also add different elements to your axes in this box here. So our x-axis is time, which is fairly universal, and here we can plot mass versus that time. There are a bunch of options that are offered, from air pressure to vertical orientation, roll rate, altitude, and everything in between. We will go with altitude for the purposes of this plot.
Wow.
So here we see the rocket takes off, hits a motor burnout, coasts to its apogee, is recovered at some point and then glides safely to the ground.
You might notice in the bottom left that there are no longer a lot of NAs. Instead, we have apogee, velocity, and acceleration as rough estimate.
By rough estimates, we mean that this number here, as you can see, 3702, is not always the simulated number. Actually, if you run multiple simulations, you may get slightly different numbers. This is just the nature of OpenRocket simulations. It's not incredibly powerful, but it does give us a good idea of our rocket. So here we can see now we have a complete rocket with simulated data, with an apogee of about 3,700 feet, Mach 0.34, and 4.6 Gs as its macros.
Congratulations, you know what OpenRocket is.
And that concludes our OpenRocket tutorials.
Yay.